Hi, I'm Tom Hackett, and today I'd like to ask you a question. What really matters when selecting IP? Now, when you ask somebody that question, they quite often spring to three letters, P, P, and A. And of course, you know what those letters are, right? It's performance, power, and area. So these have been the things that people have always been wanting out of their IP component to match the right profile of performance, power, and area for their chip. Now, that's interesting. But before we get started down that path, some of you might be saying, well, wait a minute. There's a more fundamental question that we should be asking. And that fundamental question is, of course, should we make versus buy the IP? And it used to be, several years ago, that most companies would always be biased towards making their own interface IP rather than to buy it from a commercial vendor. So they'd actually spend the resources to develop their own USB interface, their own PCI Express interface, their own DDR interface. And why did they do that? Well, a couple of reasons, really. In SoC development, it has always been, and it'll always be, a very risky business. The stakes are very high, and for the one or two companies that come out first with a great product, well, they win, they get like all the profits, and pretty much everybody else is going to lose money. So it's an inherently risky business. And so in that environment, you want to control the variables, right? And people used to think, well, if I can do all this design internally with my own staff, I have complete control over the variables and I'll reduce my risk. But something started to change about 5-6 years ago, and then 2-3 years ago really accelerated to where today almost everybody chooses to buy their interface IP versus make it themselves. And so why is that? Well, one thing is that the fact is, chips are bigger. They're big and they're complex, more so than ever before. And you have to design these things with resources that are limited. This means your engineering talent. And even though today we have large design centers in India and China, there is still more a demand for technical expertise than there are engineers to fulfill it. So limited resources are a big factor. The other thing is that expertise in these standard interfaces is rare. Now, it used to be in the old days, if you're looking at PCI Express or USB or DDR, that a particular generation would stay in place for 3, 4, 5 years. And so you could internally develop some pretty good expertise in that interface. But nowadays, these generations are coming on faster and faster, so it's harder to keep up. And they're also splitting off into a variety of sub-interfaces. There's USB Type-C that tunnels DisplayPort now through that connector. There's NVM Express in addition to PCI Express. There's all these variants that come out. So it's harder to maintain that expertise inside. And really, because of the need to bring in outside resources with the expertise, the IP is pretty much mostly being purchased now. But what about this other factor down here, which might be in your back of your mind, which is cost? Well, if you buy something, you're spending money, right? So there's a cost associated. But really the cost associated with acquiring resources and developing expertise, that tends to trump the actual physical cost of buying an IP product. And so if we think of this scale of make versus buy, it's really tipped totally into the buy direction. Okay, now let's take a look at another thing. Let's look at today's realities of chip design. So today, there are many semiconductor process choices available to you. At the most advanced nodes, you've got many choices. You can design in 16 nanometer, 14 nanometer, 12, 10, 7. And in the next few years, you could pick pretty much any digit between 10 and 3 and find a semiconductor process to match it. So, and another thing is targeted applications. It's not good enough to just have I'll say a PCI Express, in controller in PHY, but is that tuned to the special needs of the data center? Or is it does it incorporate the functional safety mechanisms needed for automotive design, right? So there's a targeted application. So when you take all these processes in the different application areas, it becomes pretty much impossible for any one IP vendor to have off the shelf at any point in time an IP portfolio that meets all those processes and all those applications. So given that the chips are getting bigger, it means that people have to bring in their IP supplier much earlier in the process, really way up front when you're architecting the chip. Because what you'll need to do is select not just from some off-the-shelf IP, but select a vendor, and really you'd like a partner that'll work with you to develop the IP that gives you the PPA that you're looking for in your target process for your target application. And so what really matters when selecting IP is really mostly about the vendor and not about the IP itself. And so that what really matters then is some characteristics about your IP partner. And I'd say, do they have the expertise that you need to designing that process, to hit that application, to work with that protocol? Do they have the consistency of delivery? And what does that mean? It really translates to, do you trust them? Do you trust that partner to deliver? Without the trust, you've got nothing, right? And then, does that partner have the flexibility to work with you through the inevitable requirements changes that are going to happen during the course of your project? And then finally, let's say your project is successful and you need to do rapidly different variants of your successful SoC. So does your IP partner then have the scalability to ramp up and produce these different variants that you're going to need? So I think all those factors, to me, kind of really answer that question and what's really important. So since you have some important choices to make here regarding your partner, I'd advise you choose wisely. So I'm Tom Hackett for Whiteboard Wednesday.